Today's learning target is I can find the least common multiple of two or more numbers. When we're asked to find the least common multiple of two or more numbers, there's a couple of ways that we can do that. One of those ways is we can list the multiples of numbers. So the multiples are just when you count by that number, those are the multiples of it. So in this case, I have 6. So if I count by sixes, I get 6, 12, 18, 24, 30. And it would go on and on and on. I'm going to stop there. Now I move to the 10 and I find the multiples of 10. And I go 10, 20, 30, and I could go on and on and on. So common multiples would be multiples that are the same for these. So in this case, okay, we see that 30 and 30 are both multiples of 30 is a multiple of 6 and 30 is also a multiple of 10. And it's the least or the smallest multiple that's the same. So in this case, the least common multiple of 6 and 10 is 30. So if you like to do it this way, you just write out the multiples for both, and then you can stop when you find the first one that's the same. We can also use prime factorization when finding the least common multiple. Okay, so here I've broken this down using the fraction trees. So I've got 2 times 3 is the prime factorization of 6, and 2 times 5 is the prime factorization of 10. So now here's what I do to figure out what would be my least common multiple. So I'm going to find each factor that appears in these, and I'm going to write it down the greatest number of times it shows up. So let me explain what I mean. There's a 2 here, and it appears once in this. There's a 2 in this factorization, and it appears once. So the most times that 2 shows up is once. So I'm going to put 1, 2 there. Now, 3 shows up once in this factorization and no times in this. So the most times 3 shows up is once. So we're going to times also by 3. And I also notice over here there's a 5. So 5 shows up in one of the factors. 5 is once here and no times here. So the most times 5 shows up in one of those factorizations is 1 time. So now I'm going to times these. So if I times these two, 2 times 3 is 6, and 6 times 5 is 30. So my least common multiple of those two would be 30. So now you know 2 ways that you can find the least common multiple. Now when we have numbers like this, 45 and 75, I could just list the multiples of them. Okay, so I've done that this way. I don't typically like to do it this way unless the multiples are easy for me to count by. So in this case, for finding the least common multiple of 45 and 75, I probably wouldn't just list the multiples because to me this is it's just not as easy. But I'm going to walk you through this one in case you like this way. So I list the multiples, and I went 45 and then 90 and then 135. And then I stopped there. And I went down to here, and I did 75, and then 150, because I'm counting by 75, so over here I could do 75 plus 75, or 75 times 2. And then I went to another one, and I got to 225, and then I went back up to here, and I kept counting, and I eventually got to 225 here as well. So my least common multiple for these two is 225. For me, if I have larger numbers, like 45 and 75, I'm going to use this method, the prime factorization. So you can see here, I found my prime factorization for 45. I went 3 times 15, and then 3 is prime, and I broke 15 down to 3 and 5. So that gave me, right here, my prime factorization for that. Then I went over to 75, and I did 25 times 3. 3 is prime. And I broke 25 into 5 and 5. So there's my prime factorization for 75. Now I look and I find out which numbers am I going to multiply. So I see there's 1 3 here, but I see there's 2 3s here. So the most number of times 3 occurs in one of these is twice, because it appeared 2 times here. So I'm going to put it down 2 times here. Okay. Now I also see that 5 appears. 5 appears one time here, but it appears twice here. So the greatest number of times 5 appears is 2 times on this side. So I'm going to times 5 times 5, so 2 5s. Now I just multiply these. So 3 times 3 is 9, and 5 times 5 is 25. So now I could just do 25 times 9, and I get, okay, 9 times 5 is 45, and 9 times 2 is 18, plus 4 is 22, so 225. Same answer I had on the last slide, it's just a different way to do it. Alright, let's take a look at this problem here. It says, Ling needs to buy paper plates, napkins, and cups for a party. Plates come in packages of 12. So I'm going to jot that down here. Plates, 12, packages of 12. Napkins come in packages of 16, and cups come in packages of 8. And here's what I'm looking for. What is the least number of packages she'll have to buy if she wants to have the same number of plates, napkins, and cups? So I can see this is a least common multiple question because I want to know the same number of plates, napkins, and cups for the least number. Okay, so I'm looking here, 8, 12, and 16. And I'm going to look for the least common multiple, and this time I have 3 numbers. Now, if you wanted to, you could list the multiples for each one of these. So you could start at 8 and keep going there. You could start here at 12 and keep going there. You could start at 16 and you could keep going there. However, I'm going to use the prime factorization method for 8, 12, and 16. So I'm going to break these down. So 4 times 2 is 8. 2 is prime, but 4 is 2 times 2. So for this one, it's 2 times 2 times 2. Okay. For 12, I'm going to get 4 times 3. 3 is prime. Put 4, I break down to 2 and 2. So I get 2 times 2 times 3. And let's see, 16 is 4 times 4. And that's going to be 2 and 2 and 2 and 2. So I get 2 times 2 times 2 times 2. So now I just need to look at each factorization here that I did and find out which one has the most factors for each number. So I start here at 2, and I can see that this one has 3 2's, this one has 2 2's, this one has 4 2's. So I'm going to take 4 2's, 2 times 2 times 2 times 2, and then I'm left with 3. There's no 3's in here, but there's 1 here and none here. So I also need to times it by 3. Alright, so I know 2 times 2 is 4, and this 2 times 2 is 4, and that's going 4 times 4 is 16, and 16 times 3 gives me 48. So my least common multiple for these 3 numbers is 48. And 48, and then the label on there would be packages. So I should have written that in there too. Packages. Sorry, it's sloppy, but